As we face challenges in sustainable agriculture and the need for effective weed management, Carbon Robotics LaserWeeder uses computer vision and AI deep learning models to identify weeds and crops in real time and to eradicate the weeds with high-powered lasers. I'm Sharon Spielman with Machine Design, and joining us today to explore the vision behind the company, as well as the vision system it uses, is the CEO of Carbon Robotics, Paul Mikesell. Thank you for being here, Paul.
Hello, yeah, thank you for having me.
So before we get started with the questions I have for you, if you want to tell me a little bit about how your company originated and give us a little background on Carbon
You
Robotics.
bet. Yeah, I have a deep and rich and long history in deep tech systems and particularly AI and robotics, and I've been doing this for a long time in many different fields, but agriculture became really fascinating to me after talking to a bunch of different farmers about the challenges that they were running into. And it became pretty obvious to me that there were solutions we could provide that other people were not focusing on, and that it was time to start putting some of that Silicon Valley money and tech behind these solutions that could really make a difference in the real world. And agriculture seemed like a great place to do it. So that's what we've been doing since 2018.
Fantastic. Do you have AI engineers? Do you have mechanical engineer? Like, can you tell me about the collaboration with them?
Yeah, we have AI engineers, we have a software team, a mechanical team, and an electrical team, and they all work together to produce these systems. So what comes out of our manufacturing is a system that is all in one, but the individual component in there is what we call a scanner that does the object tracking and targeting, and that is a combination of mechanical, electrical software and AI all running together. And you really need all those pieces because they all have to be tightly calibrated and work together. What we do is we build the system that's best targeted for what the software can achieve, right? Instead of the other way around. And I think that's why the system works so well, right? Because it's highlighting the aspects of what the software can do and really focused on that. And everything's built towards that.
So obviously, sustainability is a huge concern in modern agriculture. So how do the systems that make up your machine contribute to more sustainable farming practices?
Sure.
And then what potential impacts do you see like on herbicide use and overall environmental health?
Yeah, right. Well, you don't have to use any herbicide if you're laser weeding. So
Right.
you don't need to buy the herbicide. You don't need to spray the herbicide. You don't need to be exposed to the herbicide. The consumers don't get exposed to it. But maybe most importantly for the farmer is it doesn't knock your crops back, right? Because if you're not spraying herbicide, you're not damaging your crops. So that's the biggest benefit, I think, to the farmers from a ROI perspective, right, is yield increase. But from a sustainability and environmental impact, it's about not having to spray all those chemicals into the ground. It also means that because you're not knocking your crops back, yes, you get better yield, but you also need less of the other ancillary things it takes to grow your crops, like fertilizer and water, because you're not knocking them back. So they come to fruition with, less of all the other nutrients and materials they need because you're not continually beating them up. That's an important part of the sustainability aspect. And then the other thing is because we're not dragging blades through the ground, we don't tear up the topsoil and cause erosion and things like that. And so I think those are the two big aspects of using a laser is that you're not touching the ground, you're not spraying.
So how is the system able to adapt to the different crop types and the weed varieties in the different conditions as well?
Yeah.
I know that you have the mechanisms for continued learning, and we talked a little bit about it, but talk a little bit about that.
Yeah, I think so. A lot of this is because we're not just building the kind of classical computer vision algorithms where you're looking at object contours or edge detection or light dark shade differences, but because the neural net itself is learning these kind of higher level concepts about what the crops are, it means that it's able to adapt to different soil conditions and lighting conditions, humidity, wet, things like that, because it's learning something beyond just what the classical algorithms would teach us. In a lot of cases, it can surprise you about how well it does in a scenario where it's never seen anything like that before. And there's a certain information theory argument here about the latent factors of plants and the way the GPU is encoding these vectors. But that seems to bore out pretty well, because when we run in scenarios where we haven't seen before, the neural net does extremely well. But a lot of this is the neural net's capability to learn these higher level concepts around plants, or anything that it sees, but in our case, plants.
How fast does that machine move?
Between 1 to 2 acres an hour is kind of our average.
It would depend on how many weeds there were too.
It really does, yeah.
Yeah.
Entry timing is important. Get in early when the weeds are smaller and we can kill them quicker. It makes a huge difference.
Do you have like a feet per second that it moves? I'm trying to envision the.
Call it about a mile an hour or something like that.
So what are the KPIs? What key performance indicators do you use to evaluate the effectiveness of the vision system?
Yeah, we try to make sure that we're doing identification of weeds in the mid 90%, and then misidentification of crops less than 1%. Those are the metrics we use.
All right. Can you elaborate a little bit on the field testing phase for the machine vision system, and what real world challenges have you encountered and how are they addressed?
Yeah, I mean, we tested in the fields from 2018 until we shipped our first machines in 2022. So it was a long development cycle. I mean, in tech, that's a long development cycle. A lot of hours and years in the field trying stuff. So by the time we had machines to market, we'd been through several different generation of machine, everything from the type of optics and servos to the type of GPUs and the types of neural nets that we were using. And so a lot of this was just really those hard hours out in the field. I say hard hours because, we're out there in the hot sun, typing away on laptops and doing, pulling out multimeters and stuff in an environment that's quite a bit different than what most software engineers and electrical and mechanical folks are used to operating in, in all weather conditions, etc. But you got to do that. I think a lot of robotics companies sort of fail at that stage where it's time to do really intensive field trials, because it can be quite difficult, to get everybody out to the field all the time and test stuff over here and over there and, far away from home and family and whatnot. But you do that for a couple of years and you start to get a really good system. I mean, the biggest challenges are always environmental. It's like heat and humidity, temperature. I guess I said heat, but yeah, temperature, dust is the big one, right?
Dust, yeah.
And you just got to go headlong into those challenges. I think people have a tendency to try stuff in the lab and then never get it into the field, and then they get surprised when they try to ship it.
Sure.
And so, we were not perfect. We certainly had a lot of stuff fail when we first shipped our machines. It was all the stuff that you aren't paying attention to. It's like the air conditioning units and the chillers. It's never like the optics and the deep learning system, because that's what you're focused on. It's always the tires, stuff like that.
Do you have favorite suppliers that you go to for these, or?
Sure, yeah, we sure do. Yeah,
you sure do.
We try to multi-source every one of these things, make sure that we have many options. Most of the high quality servos come from Germany. That's maybe what you might expect. I don't know, but we try to pull the best in available parts from really around the world to make sure we're building a quality product. We have multiple suppliers for each of the parts.